Hello members, welcome to this lecture. In this discussion, we are going to look at Simpson's rules, and we are beginning with Simpson's third rule that is derived from quadratic polynomials or polynomials of degree 2, because uh, their third rule uh, assumes that the function approximates a quadratic behavior, and it is from that assumption that or that manipulation that you go ahead and determine the integral of that function over a given interval. So let's consider integrating f of x over an interval of a to b with respect to x, and this approximates to h out of 3, okay, into y naught plus yn plus 4 into whatever is having an index that is odd. So y1 plus y3 plus y5 plus dash dash up to yn minus 1. Then plus 2 into y2 plus y4 plus y6 plus dash dash up to yn minus 2. Okay, so you finish and close that. So that is the function that you are going to use to get the integral of any function using Simpson's third rule, whereby h is the width of each subinterval and your h is equal to b minus a out of n, whereby n is going to be the number of subintervals. Okay, so that means if I have, for example, 6 subintervals, I'll start from I'm going to start from y0 up to y6. That's what I mean. And I'll have x0 up to x6. That's what I'm meaning. And if that is a function that I'm looking at starting from x0, x1 up to x6. And the corresponding values will be y0 up to y6. Now let's look at if I have to apply this integral over just a single interval. So if I'm looking at a single interval and I'm using a third rule, so Simpson's rule over a single interval, okay, just a single interval, then integral from a to b of f of x with respect to x approximates b minus a out of 6 into f of a plus 4 times f of a plus b out of 2, then plus, okay, plus f of b, and that's all. So we'll have finished Simpson's third rule. Now let's talk about Simpson's 3 out of 8 rule. So Simpson's 3 out of 8 rule comes from the cubic polynomials. So I look at the polynomial and approximate it to be a cubic polynomial. That means I use a power of x power 3 or x cubed. So what does that mean? I'm going to use integral, okay, integral from a to b of f of x with respect to x, approximate it to this expansion, this is going to be 3h out of 8 into y naught plus yn, okay, plus you're going to put 3 into y1, okay, plus y2 plus y4 plus y5, okay, plus dash dash up to yn minus 1 plus n minus 1, okay. Then we are going to add 2 into, now the multiples of 3. So y3 plus y6 plus maybe y9 plus dash dash plus up to yn minus 3. And that is going to be the formula that we are going to use to calculate or to evaluate an interval using Simpson's 3 out of 8 rule. So this is Simpson's 3 out of 8 rule. Also, this h is equal to b minus a out of n, whereby n is the number of subintervals. Now, if 3 out of 8 rule is applied over just a single interval, that is AB, okay. So if we apply it over a single interval, then a to b of f of x with respect to x will approximate to, is going to approximate to 3 out of 8h into f of a plus 3f of a plus h plus 3f of a plus 2h plus f of b, whereby h is equal to b minus a out of 3. So whereby now h, of course, is talking about the width. H is the width of each subinterval. Of course, it is going to be over a single interval, but then you can divide it into 3. So that is only applied when you are able to, okay, when you are able to divide this single interval into 3 subintervals. So that means applied when only you can divide the interval into 3 subintervals conveniently. For example, if we are talking about the interval of 0 to 6, so that means you can evaluate this interval, you can evaluate this integral over 0 to 2, okay? Then you have also 2 to 4, then you have 4 to 6. So use this only if you can divide this interval into 3 subintervals. Then it is from here, okay, is from here that obviously your h, like your h is going to be, so that means if I consider this, your h is going to be 6 minus 0 divided by 3, and that is going to be 2. So if it is 2, then I'm going to be looking for, I'm going to evaluate for f of 0, okay, I'll evaluate for f of 0, then f of b, which is f of 6, then I also need to evaluate f of, this is 0 plus 2, so I'll also evaluate f of 2, Then for f of a plus 2h, so which will be also f of 0 plus 2h. 2h is 2 times 2, which is 4. So I'll be able to evaluate that, substitute in this formula, and then be able to get the integral of that function over that interval. So in the next lecture, we are going to be looking at how we can utilize the two rules in order to determine the integral of any function.